In this episode of Finno-Ugric Machining, we are going to, mill a slot into this piece. And this is, the slot is for the contact, for the grounding contact for the welding thing. It carries quite a lot of current, and this is very important to be there. If you don't have it and you are just grounding through the bearings, it will destroy your bearings in no time. So therefore it's important to make a grounding contact that really makes a contact. And for this reason I'm milling a slot here through the wall of this one, and then in the slot there will be a grounding thing which is made out of brass, and it will be forced into the shaft, so it will make a decent and very reliable contact with the shaft. Okay. So our first task is to attach this piece into the table. Well, it's probably a simple thing, or is it? So just let's go on with that one. The intuitive way of doing this would be to use one of these like that, and then just put it into there like that. Put it there, and then have your support here on the back side, and well, there you would be. Just tighten it. No, that's and here comes the funny part, because you cannot do it exactly like that. Well, yeah, and the reason is that this groove here, the white is only, well, maybe 12 millimeters. So and the height here is, so there will be a lot of forces pulling it up if this is bent like this. So for that reason we need to support it from a larger area. Okay, lucky of us we have these machinist clamps, and I have found out that okay, one can use these like this. So you put it there and there, and okay, wrong way. I would like to have it this way, a little bit wider. Okay, now it goes there. So now when I put it here, so I can tighten these from the, first of all, so we can use the machinist vise here. This one is, so you put it here like that, tighten this, and then after this is tight, you can tighten this one as well. So now it supports it from a much wider area from the sides, and doesn't allow it to as easily to tilt sideways. And this probably, if you wouldn't use it, you might even break your table, because the forces involved when you bend it like that are really great. So, well, I will do it like this, and the other side will be identical to this one. Oh yeah, nothing fancy about that. Well, now we should set the y-axis, this axis, so that this is on the center line. Okay, so I don't have a center finder or edge finder long enough to be able to detect this corner here. So I have this precision shaft, which is 16 millimeters in diameter. Put it into my into my collet, and now I have my feeler gauge, which is this piece of office paper, 0.1 millimeter thick, and now I'm wiggling it here on the back side and then approaching. Oh, that was too soon. Let's see when it touches. Yeah, there it is. And then I adjust my dial here so that it's 0.1 millimeter from. So now this is done, and now we know that this is actually now it is exactly half of the diameter of this one, which is 8 millimeters. This is 16, so 8 millimeters away from the edge. So I have my 0 there, so now I can remove this. And if you wonder this paper, well, it's to catch the oil that's dripping from my spindle. Yeah, I oiled it, and now it's dripping. It's always like that. Yeah, but it stops after a while. So now, next thing, we first go to the 0, which was that, and then we go half of the width of this diameter, which is, it should be 8 millimeters, so 2 turns here. 1, 2, like that. Now it's on the edge. And then I measured the diameter of this one, and it is 123.7 millimeters. Divide that by 2. Where is my calculator? Oh, there it is. It's something like 60, but I don't. 123.7 divided by 2 equals 61.85. Okay, 61.85. Well, let's divide that by 4. It's 4 millimeters per revolution. So divided by 4 equals 15.46 turns. 15 turns. 15. Okay. 15. First 15. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yto, kato, koto, neto. Now we have 15 turns there. Okay. 15 times 4 equals to 60. Now 1.85 millimeters more. Okay. That's our 1.85. Yeah. 0.80 and 5. Yeah. 5. Oh. Even though this has quite large dials, they are still, for me, hard to read without this. Okay, 85. So it's there. Lock it. And now, again, backslash. I was turning it clockwise. And well, as always, I put my backslash in the clockwise direction. So now if I need to go back to that one, I know that if I want to eliminate the backslash, I need to take care of that. Now I can zero this one. So it's in the middle of the, it seems like it's in the middle. And then we have one more dial here, which I would like to put on some figure, which is, in this case we do have here 10. Does it reach? No, it doesn't reach, so we put it on 9. In case we need to return to this place. So now I know. Okay, that's there. And there is oil. Okay, we are in the center of that thing now. And this is locked. Well, that was that. Next thing is to determine what is our position in X. Well, let me do some planning, and after that we know. Well, this is the material I'm going to use for this contactor, the grounding contactor. It's 40 by 40 millimeters bearing brass. I don't know what kind of brass is this, maybe aluminium, bronze. No, it's not brass, it's bronze. So, yeah, and so what I'm going to do is to use it 60 millimeters wide and 30 millimeters wide and 60 millimeters long hole in there. And yeah, okay, that's about the correct dimensions for this material. So, what I'm going to do next, I'm going to drill 4 5 millimeter holes here, starting with 15 millimeter spacing. So there will be 4. One is 7.5 millimeters from this point. Next is 15 millimeters more. Next is 15 millimeters more, and the last one will be whatever it is. So there will be 4 of those, and it's the 5 millimeter drill I'm going to use. And when I have done those all the way through, I will widen them with a 15 millimeter drill. Well, those holes serve as they make the milling process a lot easier, because the chip evacuation works better when you have holes there. Okay? Okay, here I am now making the next 3 millimeter pass downwards. So I will go around 3 millimeter passes until we are through. This is now the third, so I have already done 2 of these passes. And now first thing is to start it up, because when I will go down, let's see now. It's so 3 millimeters. That's 1.5, and that's 3. Okay, and then I release the Y lock now, and then we go the first. Of course, we need some lubrication here. I will do the first the Y-axis in correct place. And the chips are really evacuating into the hole. So that's really nice thing about this this method of doing the thing. So it will be 8 millimeters to this direction from the center. And we are now just the backslash. And there you are. It should be, yeah, it is. And then I release start the feed. But before that I will clear the chips. Put some lubrication here. Start the feed, release the X, and away we go. There you are. Another 3 millimeter pass done. And the chips are really evacuating into the holes. As you can see, there is not much chips here, but here, oh well, let me show you. Here in the hole you have a lot of them. They are all there. So now I just repeat this until I'm through. Will take some time. So this is now the last pass. Well, it was not too tedious. It's about 10 rounds and then you are done. But now this should break it through. So let's start. Well, we are officially through. Well, it's not beautiful. The surface finish is very uneven. Well, but that's not a problem. I will. The next step will be climb milling all around this hole. So yeah, and that's what I will be doing next. Well. Now that we have a decent hole here with smooth sides, so now I will do solder around this hole. It will be at this direction, it will be 30 millimeters longer, and it will be 4 millimeters wider. And since the radius of this is 7 millimeters, well, shouldn't be too bad to calculate how much we go from the 0 point, which is actually on the well, edge of this hole. So it will be 23 millimeters this direction from the 0 point. Okay, so let's do that now. And yeah, hopefully we don't get any trouble with ship evacuation. It's always possible. So let's go. This is a 3 millimeter cut. Okay. Then I just do this same process like 3 more times to gain 12 millimeter depth here. So now that we have made these recesses for the contactor here, so the next step is to make 2 M6 threads here. So first I drill with the minor diameter drill, which is 5 millimeters, the recommended, and then I will just tap the threads there. Wow. So now we have the threads here. Well, next thing is to, turn it around. Maybe do some cleanup. I would turn it 180 degrees, and after that I will drill a hole. I would like it to be, there will be an M12 thread. there is the hole, and now tapping. So now, one of the last operations, tapping M12 thread here. So yeah, I have this is my automatic punch, the marker. I ran out of Z-axis with this tap follower, so I need to be a little bit creative here. And this one is a straight flute tap, meaning that I must break the chip every turn or so, like that. Oh, yeah. Otherwise it will bind. Like that. More cutting fluid there. Let's do it. Yeah, it starts to be crunchy. I think I need to clear the chip soon. Yeah. Yeah, better early than too late. Yeah. Okay. Where is that thing? Okay. Yeah. Well, because this one doesn't evacuate the chips, it just collects them into the flutes. So therefore I really need to... this is not funny. Okay. We were almost through, but there you are. Better to be safe than sorry. Breaking the tap here now would be... oh, it binds sometimes. Really it does. Let's see what it looks like. No, we are not even near. Oh. I think I need to tighten this somehow, because now we are through. Yes. Got it through. Whew. Without breaking it there. Yes. It's tight somehow. Well, there you are. Oh yeah, let me show you about this. It collects the chips in the flutes. So with the spiral flute it will push them up, and with the Contactor it will push them down as a continuous chip. But this one makes these little things that block this if you are not careful. So next operation will be deburring a lot of that. So now this part is ready. Well, almost ready. We need to do some sort of attachment for the motor and the gear system on the other end. But as of at the moment I don't know how to do that. Well, I have some ideas, but I'm not sure. So I let it be until I'm sure. So I consider this being done at the moment. So the next thing we are going to do in the next episode of Brick Machining will be the shaft itself. I will be using that material, and well, there will be threads and long hole, and you can there is a lot of turning. Most of it will be lathe work, well, most if not all. So yeah. But that will be in the next episode of Brick Machining. Till then, see you!